to talk about section 8.4. And we're going to start off with just, well, there we go. Okay, just the basics. So 8.4 is simplifying multiplying and dividing rational expressions. Okay. Sorry about the background noises you might be hearing. There's a rabbit sitting behind me chewing on things, so that's what that is. Alright, so we're going to start with just the idea of simplifying fractions in general. Because it's probably been a while for many of you. So if I have 12 divided by 18 and I want to simplify this, then there's a couple of ways to think about this, but I want us to think about this in terms of factors. So what's the greatest common factor of 12 and 18? Well, that would be 6. So I could rewrite 12 as 6 times 2, and I could rewrite 18 as 6 times 3. Okay, and so then I know that 6 divided by 6 is 1. So I'm left with 2/3, right? Because 1 times 2 is just 2. So because this is all multiplication, the 1 kind of just disappears, and we're just left with 2/3. Okay? So the same is true if we have variables involved as well. So if I have, I don't know why it's doing that weird focus thing. Let's see if I zoom in a little. Sorry about that, guys. If I have 3x squared divided by 9x, well, I could do the same thing. I could think of this as 3xx over 3 times x, and then 3 divided by 3 is 1, x divided by x is 1, and I am left with x3 or x3rds. Another way to do this, instead of writing the whole thing out, is we could just cancel it out in here. So I could say, if I have 3 here, then this 3 is gone, and here I'm left with 3. And I can cancel these out. The x's are gone, and here I'm left with x on top, and then it's the same way. So it's just another way that I've seen people do this without rewriting the whole thing. Okay. All right. Next, then we can use this to help us multiply. So 3x cubed divided by 8x times 4x squared divided by 6x squared. Oh, actually I'm getting ahead of myself, aren't I? Let's back up a second. Okay, let's just start with a basic fraction. 1/2 times 4/3. Okay, 1/2 times 4/3. So when we multiply fractions, sorry, this is still a little damp. We just multiply straight across the top and straight across the bottom. So 1 times 4 is 4, 2 times 3 is 6, and then I can simplify that. These are both divisible by 2, so that would be 2 left here and 3 left here. So there's my answer. Now, thinking about this whole idea that we're going to be using more complex things and wanting to simplify first, I can also, so this is the same problem, I can also cross cancel. So if we think about this fraction, because it's multiplication, really it's just like one giant fraction, right? And so I can cross out things from either side. So here I just simplified within a fraction, but here I could simplify tops and bottoms across the two fractions. So if I think about 4 divided by 2, well, that's just 2. So now I have 1 times 2 is 2, and this is 3, 2/3. Okay. So now let's go to that other one. So 3x cubed divided by 8x times 4x squared divided by 6x squared. So same idea here. I'm going to show you a couple ways to do this one, because the beauty of these is there's not one right way to do them. There's lots of different pathways you could take to finding the solution. So I'll show you a few. So the first one would be multiply everything first and then simplify. So this would be 12x to the 5th over 48x to the 3rd. And then 12/48 is 1/4. And x to the 5th over x to the 3rd is x squared. So this is x squared over 4. Okay, so that's one way. For a problem like this, that might even be the easiest way. But as things get more and more complicated, multiplying them out first and then simplifying is going to get a lot less efficient. So I'm going to show you how we could simplify first and then multiply. Okay, so same problem. I see x squared over x squared, so that's gone, and that's just 1. And I see, remember this is like one giant fraction, so I see 4 over 8, so that's going to be 1/2. And I see 3 over 6, which is also 1/2. And then I see x to the 3rd divided by x, well, that's going to leave x squared here. So now, going across the top, I have 1 times x squared times 1 times 1, which is x squared. And going across the bottom, I have 2 times 2, which is 4. So there's another way to tackle that one. Or we could rewrite this expanded. So 3 times x times x times x times 2 times 2 times x over 2 times 2 times 2 times x times 2 times 3 times x times x. So I've broken everything down into prime factors. And now I am going to, oops, there we go, cross out anything that's the same. So 3 and 3, 2 and 2, 2 and 2, x and x, x and x, x and x. And so I am left with 2 x's on top and 2 2's on the bottom. So you get the same answer all 3 ways, but these are just 3 different ways to do it. And I'm sure there's more, and you might do it slightly different. I think people see these differently, so I'm just kind of trying to show you some different pathways that you might take. Okay. And then last we have division. Okay, so again, remember, I've gotten a drop of water on here. When we divide fractions, we can see this as doing the inverse. So instead of dividing, I am going to multiply by the inverse, right? So I'm doing the opposite operation here and the opposite here. This one stays the same though, okay? So 1/2 stays 1/2, division becomes multiplication, and then we flip the second fraction. And now we can just multiply straight across. 1 times 3 is 3, 2 times 2 is 4, so my answer is 3/4. Okay, so let's do that again. 4 over 6x squared divided by 3x squared over 9x. So my first step, keep this first fraction the same, change the division to multiplication, flip the second fraction. Okay, and now I can use any of these methods to simplify this, because now it's just multiplication again. So I'm going to, let's see, 9 divided by 3 is 3, and this is just x, and this is 2, and 4 divided by 2 is 2 up here. So I have 2 in the numerator, and x squared times another x is x cubed in the denominator. Okay. And like I said, there's lots of different pathways you could take. All right, that's it.